This is a question on Faraday's law and AC generator. We also need to know a bit of Ohm's law for us to analyze the last option about the resistor. So the answer to this question is C. There are three changes here that will affect the value of the EMF. So we will be using Faraday's law, and when we want to increase the induced EMF, we will have to increase the rate of change of magnetic flux that the coil experiences. And the few ways of doing so would be to increase the number of turns in the coil. Over in the picture here, you see one turn. We could have put in like many turns of the coil, and that will increase the amount of the induced EMF and induced currents. The speed of rotation, definitely rotate faster, you're converting more mechanical energy into electrical energy. And lastly, the magnetic field strength of the magnet. The stronger the magnet you use, the higher the induced EMF or induced currents. Now, when we change the resistance of the resistor in the external circuit, we will affect the induced current that flows, because current depends on two things: the EMF that is induced and also the resistance. So altering one of these two, including altering the resistance, will affect the induced current. However, the resistance does not affect the induced EMF. It only affects the induced currents. Induced EMF is from the power source. In this case, the power source is Faraday is the effect of Faraday's law, and is the coil itself. And the resistance in the external circuit has nothing to do with the induced EMF in the coil. They are two separate things. So the value of the resistor does not affect the induced EMF generated in the coil, simply because the resistor is not found in the coil, it's outside.